Okay, this is a three-part assignment. I'm going to have you forwarding to the assignment at various points, okay, in the video, so it doesn't get all overwhelming. Find the value of each expression. This means the square root of 25. Now, one thing you've never seen is that's actually a 2 right there, okay? It means what times itself used as a factor twice gives you 25. I mean, is it 1? No. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5, bingo. So it's 5. Now, this is a cubed root. Maybe you've seen it, maybe you haven't. It's similar to a square root, but now you're finding what times what, the same factor, equals 125. Okay? I don't think it's 1. Is it 2 times 2 times 2? No. Nope. Trial and error. Nope. Cha-ching. 5. Okay. The fourth root is 16. The answer is not 4. That would be if it's a square root. So a fourth root is what times what times what times what equals 16. It's not 1, because 1 times 1, 1 times itself, no matter how many times, is 1. Let's try 2. Cha-ching. Okay. 2. Cubed root of 8. What times what times what? 3 factors, because it's a cubed root, equals 8. It's not 1. 2. Okay. Pause the video, go to the back, and do numbers 1 through 4. Okay. Do 1 through 4 on the assignment, then I will continue. Okay, that shouldn't have been too terribly hard. Now, rewrite the expression in radical form. Now you're wondering, what's a radical? A radical is a root. Okay, it's the same thing. That thing right there is called a radical. So on the first page, this stuff here, these little signs, or roots, are also known as radicals. Now, what you're going to see is these exponents that are fractions. Okay, they're called rational exponents. They're really radicals. Okay, here's how you do this. You're going to line up the 3 lines, but you'll never have to use this because you won't come across any negative exponents. Okay, so you won't have any negatives that you have to move. So you got a base m, it's to the 1/2 power. Now, you're like, well, I can't simplify m. Yeah, but you need to write it in radical form. Here's how this is done. You make a radical, better than that, hopefully. You circle the bottom. You put that in the radical index. That means it's a square root, okay? Then you cross that out, and inside you put m to the 1st power. If it's to the 1st, you don't even need to write the 1st, but I'll put it there. That's the answer, okay? That's how you do it with a variable. Now, what happens when you get a number? Well, you need to try simplifying it. You don't need that. So, the factors you have are 36 times x. 1, 1. 1 times 1/2 is 1/2. 1 times 1/2 is 1/2. Now, this time you actually have a number. Now, here's what you do with that. Circle the 36 and the 2. Okay, not the 1. The 1's going to stay put. You don't do this when you have a variable, but when you have a number, this is what you do. Then go to the scratch paper I provided you with, and it's a 2. It is a 2. So blank times blank equals 36. If that was a 3, I'd write blank, blank, blank. And I have to come up with the number that's 36. It's like the square root of 36. I don't think it's 1. I don't think it's 2. I don't think it's 3. I don't think it's 4. Don't think it's 5. Aha, 6. So what you do is you cross that out and put 6. So you now have 6 to the 1st power, which is 6. Now with the variable, you need to make the radical because you can't simplify a variable. So you make a radical, you put 2 in the index, and you put x inside. That's x to the 1st power. Okay, that's it. I'm going to do several more. Okay, you got 49 times x. This is different. Okay, they're trying to trick you. 49 is to the 1, but it ain't in parentheses like the 36 was, so it just stays to the 1. And then it's x to the half power. So 49 to the 1 is easy. It's just 49. There's no bottom number with the 1. They want to trick you and make you put a half there and do like you did with the 36, but no. Okay? Now the variable needs to have a radical. Circle the bottom, and that's the radical you put in the index, and then x to the first. Okay. Okay, now we're back to having the number in parentheses. This time it's to the 1/3 power. Okay. So you have 125 times x. 1, they're both in parentheses, so they both multiplied by 1/3. So 1/3, 1/3. Okay, now you need to simplify. Now how do you simplify the base, the numerical base? Well, you circle this, go off to your scratch paper, and you go blank times blank times blank. 3 of them, because it's a 3 on the bottom, equals 125. Okay. I don't think it's 1, probably not 2, 3, no, nope, cha-ching, 5. So this right here goes to a 5. Now it's 5 to the first power, but 5 to the first power is just 5. Now with the variable, you can't evaluate that, so you make a radical. This time we put a 3 in the index with x to the first. Okay, let's keep it rolling here. Same thing. Don't need that. So the base is, you got 81 times x. Now 81's to the first, but that ain't in a parentheses, so it's just to the first. Only the x is to the 3/4 power. So 81 to the first is easy. It's 81. There's no bottom number with the 1 that I need to go off to scratch paper and figure out the root degree. Then circle your bottom, make a radical. This time it's a 4th root, and inside we put x to the 3rd. Okay, 20 times a. So again, 20 is not in the parentheses, so it's just 1. The a is the only one that has the 1/3. So 20 to the first is 20. Then for the a, we make a radical with a 3. And that takes that out, and we have a to the first. If it's to the first, you can just put, you don't have to put the first, but it's up to you. Now, if it's to the 3rd, I need to see the 3rd, but a variable to the first would just be the variable. Okay, parentheses 16x to the 3/4 power. So I've got 16 times x. Both of them in parentheses, so they both are multiplied. Their first powers are each multiplied by 3/4. They need to be distributed. Okay, now 16, you got to evaluate the 4th root of 16. Okay, so scratch paper, what times what times what times what equals 16, because it's a 4. Relatively sure it's not 1. Okay, it's 2. So you cross out the 16 and the 4 and put 2, but it's 2 to the 3rd power. So 2 to the 3rd power would mean 2 times 2 times 2, just on the main paper, equals 8. Now your variable, you can't, so you make a 4th root. That's gone. And then x to the 3rd inside. Okay, and then the last one before I turn you loose on the second section. Okay, 8y to the 2/3 power. So the bases you're dealing with, you don't have to use that because you're not going to have any negative exponents, are 8 times y. Okay, so nothing's in parentheses, so I don't distribute. Okay, so 8 to the 1 is 8. And then with this rational exponent, if it's a fraction exponent, the terminology for that's rational exponent. Circle the bottom, and that's what kind of radical you make. And inside the radical, you put the base with its top exponent. Okay, hopefully that made sense. Go do 5 through 11 on your assignment. Pause me, go do 5 through 11. Okay, now for the last part, rewrite in exponent form. Now you see a radical, you got to write it in exponent. Very similar to what you were just doing, but there's one big difference. Look at the inside of the radical, okay? Just look at the inside. Don't even worry about the fourth. The only base you have inside is an x. It's to the third power. Now, after you've written that down, you underline the exponent and put a 4 there, okay? And there's no way you can simplify that, so you just leave that then in exponent form. That's what that means. Okay, next one. Remember, put a 2 there if you don't have a root. That means it's automatically a 2. It's not a 1. There's no such thing as a first root, a second root, square root, yeah. So inside you got 3 times x. Both to the first power, and you need to distribute both of them to 4. So 1 times 4 is 4, 1 times 4 is 4. Now you need to underline both of them because they were both in the root and put a 2 there. Now up here we just left it 3/4. Why? Because 3 divided by 4 is a decimal. 4 divided by 2 is not a decimal. 4 divided by 2 is 2. So you need to put that. If it divides into a whole number, put the whole number. So now 3 to the second is 9, and then x to the second stays x to the second, exponent form. Because 3 to the second, 3 times 3, it's 9. Okay, this one here, just look at the inside. You got 27 times x. 27 is not in parentheses, so it just has a 1, okay? The 2, so again, if they're not in parentheses, we don't distribute. But they both need to have 3's underneath. 1 divided by 3 is a decimal, okay? So leave it 1/3, so it's 2 divided by 3. Now evaluate. Remember how to evaluate the 27 and the 3. That means the cubed root of 27. So what times what times what equals 27. Okay. I don't think it's 1. Get rid of that. Okay. That's 8. How about 3? Ah, it's 3. So cross that out and put 3. 3 to the first is 3. And then you just leave that with its exponent. Okay. On this part. That's why I'm splitting up the assignment so you don't get all confused on how the answer looks at the end. Okay. Okay, get rid of that middle one. So you got 16x. Okay. 1's, but they both need to be multiplied because they're in parentheses. So 3, 3. Then to get rid of the radical, you just put a 4 under each exponent. Now you evaluate what you can. You can't evaluate the variable, and the variable needs to stay as an exponent. That's why it says rewrite in exponential form. Okay. But the number you can figure out. Okay. So the fourth root of 16. Let's get rid of that 4. What times what times what times what, because it's a 4 equals 16. Is it 1? I don't think it is. It's 2. So this is replaced with 2, but it's 2 to the third power. So on this paper, I just go 2, 2, 2, and that's 8. So 8 times x to the 3/4 power. Okay, so inside our radical we have a base 64 and a base of x. 64 to the 1, but it's not in a parentheses, so it just stays to the 1, and then a 2. Now we get rid of the radical by just putting a 3 there. Now we want it to stay as an exponent, so the variable stays, but the number can be evaluated. Okay, so on a piece of scratch paper, what times what times what, because it's a 3, is 64. Highly doubt it's 1. Nope. Nope. There we go. Okay. So this is 4, and then 4 to the power of 1 is 4. So 4 times x to the 2/3 power. Okay. So you have 256 times x. Put a 1, not in parentheses, so it stays a 1, and that's a 3. Now we take out the radical by raising each exponent, just putting a 4 underneath there. So remember, they want this in exponent form. They don't want the radicals, so we keep the x because there's no way to evaluate that exponent. Then, 4th root of 256. What times what times what times what equals 256? I don't think it's 1. 2, no. 3, no. You got to be patient. Boom, 4. So this is 4, and 4 to the power of 1 would be 4. So 4 times x to the 3/4 power. Okay, inside the radical we have bases x and y. Now, no parentheses, so it's just a 6 and a 9, and we put a 3. Now, I'm pretty sure 6 divided by 3 simplifies to 2. See, if they simplify to whole integer values, whole numbers, you need to do that, okay? So x to the second, y to the third, and that's pretty much the end, okay? We don't have a number, a base number to simplify. Okay, then finally, last problem. The 4th root of 81 x to the second power. So we have 81 times x, okay? That'd be a 1, doesn't get distributed, and that'd be a 2. Both of them go over 4. Okay, now the x, again, that's going to stay. You can reduce it to a half or just leave it 2 over 4. It's not going to be a whole number either, any way you slice it. Now we evaluate 81 to the 1/4 power. Now remember how you do that. You figure out what the bottom is by what times what times what times what equals 81. I don't think it's 1. No. Cha-ching, 9. Or no, 3. The 3, not 9. If it's a 2, it'd be a 9, but it's a 4, so it'll be a 3. And then I evaluate 3 to the first, which is 3. So 3 times x to the 2/4 or x to the 1/2. I don't really care about them being reduced, but I do expect to see whole numbers where needed.